The notes for today are vertex form of an absolute value equation. We're going to start with the warm-up, a little review of what we did yesterday. Number 1 says, what is the parent function of the absolute value function family? So the parent function just means your f of x is equal to, and if we have an absolute value, we're just going to have an absolute value of x, meaning nothing was changed from the original form. That's what it means to be a parent function, the original function. Number 2, it says to describe how the following functions compare to the parent function. So in regards to number 1, how does it change in A, B, C, D, E, and F? So when we look at part A, I see that inside the absolute value we have a -5. Inside means that it's going to shift it left or right, and it's opposite of what we think. So this is going to shift 5 units to the right. Part B. If we take a look, we have a +9. That's on the outside. Outside just shifts up and down exactly what we think. So this is going to shift 9 up. Part C, f of x is equal to, we have an opposite. Opposite on the outside, opposite in general. That negative means it's going to reflect. If it's on the outside, that means that we are shifting, in this case, across the x-axis because it's going to shift an up or down shift. So we're going to reflect over the, or across the x-axis, right? Outside means up and down. So if you think up and down, the x-axis is what it's going to flip over. Part D, we have 2 things going on. We have this 3 on the outside and we have that -2. So that 3 on the outside, that first thing, that's going to end up making it get really tall. It's going to be a vertical stretch by 3. And then we have a -2, that -2 on the outside. Outside shifts things up and down. So that means we're going to go, it's going to shift down 2 units. Take a look at part E. I see a 1/4 on the outside. Well, when we had the 3 on the outside of part D, that was a vertical stretch. It got bigger. So a 1/4 on the outside means that it's going to get smaller. It's going to be that vertical compression. By the 1/4. And the other piece that we have is an inside +6. Now inside we have to put inside of our head and do opposite of what we think. This is going to shift 6 units to the left. Part F. We have 3 things. I see a negative in the front, a +7 inside, and a -2 on the outside. So start with the first piece. That minus or that negative on the outside is going to be just like part C. So that means we're going to reflect across x-axis. We have that 7 on the inside, opposite of what we think because we're inside of our brain thinking about it. That's going to shift left 7. And then it's going to go down 2. Right? The next part, it talks about horizontal and vertical shifts. Describe the location of the vertex. So we're going to look for those horizontal, how things changed left and right, and then vertical shifts, how things change up and down. And that's going to tell us what the location of our vertex is. So we're not going to take the inside of the absolute value and set it equal to 0 to find the vertex. Now we're going to be able to just look at the function and find exactly where the vertex is. So we are doing what's called the vertex form of an absolute value function. And that's going to be written as f of x is equal to a times x minus h plus k. And they're going to tell us that whatever that h value is and whatever that k value is going to be the vertex. Now, I'm going to point out, see how there's that minus sign? Right? H is just the value after the minus sign. So h is the value after that subtraction sign. Now, the a value in the very front is going to act as the slope. All right, think about a slope, a rise over run, but it's only going to the right side. All right, so we're going to rise over run for the slope, but it's only going to go to the right side of the vertex. And a negative a, or the opposite of a, is going to be the slope on the left-hand side. So whatever A is going to be the slope off to the right-hand side, and a negative A, or remember negative is opposite of A, is going to be the slope off to the left-hand side. Let's take a look at number one. It gives us f of x is equal to x minus 2, and then we have a minus 4. So in order to find our vertex, we are going to identify, they said we need the vertex is h comma k. That means we need to look at our h value and our k value. So this is going to be our h value, this is going to be our k value. So the h value is going to be 2, and the k value is going to be negative 4. So we're going to start by plotting our vertex. The vertex is going to be over at 2, down at negative 4, and we're going to put a point on our graph at 2, negative 4. And then what we're going to do is we're going to use the slope. All right, so step number 1, we're going to plot the vertex. Step number 2, we're going to use the slope. And if you remember what we just said above, the slope means to look at the a value, meaning what is in front of those absolute value bars. Well, if we have an absolute value of x minus 2 and then minus 4, the a value is what number would be in front of this absolute value? The a value is going to be 1, which just means we're going to rise 1 and run 1 for our slope. So we're going to go up 1, over 1, up 1, over 1, up 1, over 1 off to the right-hand side. And then to the left-hand side, we're just going to go up 1 to the left 1. We're just going to make our V-shaped graph. And then take your ruler or freehand it, make your V shape. We're going to skip on over and take a look at number 5. Number 5. Step number 1, we need to figure out what our vertex is, right? Our vertex, that means we're going to identify whatever the h value is and whatever the k value is. Well, in regards to this x plus 1, that's really x minus a negative 1. That means our h value is going to be a negative 1, and our k value is going to be a negative 1. So h is going to be a negative 1, and k value is going to be a negative 1, which means our vertex is going to end up being at a negative 1, negative 1. From there, we'll go over to our graph, and we'll plot negative 1, negative 1. That's where our vertex is going to be located. Step number 2, we need to know what the slope is. The slope is going to be found by that a value, which in this case is what is right in front. Our slope is going to be a 2/3. So going off to that right-hand side of the vertex, we're going to go up 2 over 3. So up 1, 2, over 1, 2, 3. Up 1, 2, over to the right 3. Up 2 over 3. And then the left side means that we're going to do the opposite of it. So we're going to go negative 2, 3, or in this case, I'm going to go up 2 and use the negative towards the 3 that way. Because again, we're making that V-shaped graph, and then we're going to draw our lines through and call it done. That's it. Number 8, we're going to do as well. Number 8, graphing a piecewise function. So number 8. The first piece we have is an absolute value. So let's identify the vertex. Vertex is going to be, what's going to be our h value? Remember, this is going to be a minus a negative 1. X value, negative 1. And then the y value is going to be at a positive 5. Are we going to see that vertex? We're not going to see that vertex, right? Because what are we allowed to graph? We're only allowed to graph when x is less than a negative 4. So we're not going to be able to see that if we're at a negative 1. So we're not going to see that. So let's see what we can do. We'll start mapping it out, and then we'll just erase some points that we got. So we're going to put a vertex at negative 1, positive 1, 2, 3, 4, 5. And then take a look at the slope, right? What's our slope going to be? Right in front of those absolute value bars, it just has a negative, so we're going to have a negative 1. So off to the right, we're going to go down 1, over 1, down 1, over 1, down 1, over 1. Or we're going to go to the left, that opposite direction. But remember, what are we allowed to show on our graph? It says only when x is less than a negative 1, 2, 3, 4, right? I'm only allowed to show that piece of the graph. So what type of endpoint do we have? We have a solid circle. And I'm going to map out what I'm allowed to show off of that absolute value. And now I'm going to erase all that other stuff because I'm not allowed to show any of that stuff on my graph. Let's go ahead to the next piece. The next piece just gives us 3. Remember, that just means we have y is equal to 3. That means we have a horizontal line, and it's going to start at -4 and end at +2, and they're both going to be open circles. So if I have a horizontal line at +3, technically I'd have this whole horizontal line, but it only tells us that we're allowed to start at -4 with an open circle and stop at +2 with an open circle, and all we're allowed to have is what's in between those two, which means I can't show any of the rest of that line. And then my last piece. My last piece gives us, we have a -1 slope and a y-intercept of 7, so we'll start mapping that out, but we're only allowed to draw when x is greater than or equal to 2. So +1, 2, 3, 4, 5, 6, 7. A -1 over 1, we're going to start mapping out that line. I'm going to have a closed circle at +2. I'm going to go off to the spot that I'm allowed to show. I'm going to erase what I'm not allowed to have. And they didn't even ask us for domain and range, so guess what? You're done. If you need to, watch the video again. If you have questions, ask a classmate. If you need, you could always email me.